Okay, Tyler, thanks for that advice. Okay, let's get going. Like I said, I want to try to do this in about 15-20 minutes, and we can give you 15-20 minutes to work on the worksheet, and then we can do 1-7. How's that sound for a plan? Send your due date for 1-3 since there was no sound on the video. Fair enough?
Fair enough.
All right. So, I do want to be fair with you. Stuff like this happens. I'm never going to hold it against you, right? I'm always going to give you the opportunity to be successful in here. However, like I said, now's the time. All the class rules, everything goes like it's supposed to go. Then we follow the class rules like we talked about the first week. We've been transitioning to those rules, but now we're out of the transition period. We're into our school year. So distance on a number line. You don't have to, I've got this covered, but you guys all have this already. I forgot that it was typed on your paper. So, distance on a number line is just the distance between 2 points. If I wanted to know the distance between W and X, I can't just count 1, 2 units. Distance is always positive, right? So that's the worksheet for yesterday. You didn't get the notes. That's why I asked you. Okay? Alright, so the distance between 2 points, we can just count. But let's say we had a number line, and so we will call this the coordinates of point W here, -2. On a number line, we do have coordinates, just like we have coordinates on a coordinate plane. So this is point W, its coordinate is -2 on the number line. It doesn't have 2 coordinates, because there's only left or right or up. You can turn this up on its end as well. There's only 1 coordinate. The coordinate for W is -2. The coordinate for R is 4. The coordinate for X is 0. Now there are other numbers in this number line, but there are no points plotted on those other points, right? So if we want to know the distance between point W and point X, we can just count 1, 2. But what if we had, what if they wanted us to find, if they had a number line and it had negative 223 for W and positive 258 for Y, right? And they wanted us to find the distance between the 2 points. Well, that would be a little bit hard to count, right? There's a couple ways around it, but we're going to use this formula. The formula is the absolute value of the difference of the coordinates. Does anybody remember what absolute value is? Tyler?
Basically, just whatever number you're using, positive. Or basically how much it is.
So that is how we can find the absolute value. But what is the definition of absolute value? What does it mean? We're talking about math. Absolute value. Yes. Perfect. Distance from 0. So how far is point W from 0? How far is -2 from 0? Well, it's 1, 2, right? How far is 6 from 0? It's 6. But if we want to find the distance between point R and W, that's the same as finding the length of a segment between point R and point W. Does that make sense to Jerry? Okay. So we can use the formula and the absolute value. Absolute value, I'm just going to call it coordinate 1 minus coordinate 2, right? So coordinate is the number that goes with the point. Difference means subtraction, right? Difference tells us we're subtracting. If it was the word sum, it would tell us we're doing what? Adding. If it had the word product, it would tell us we're doing what? If it had the word quotient, it would tell us we're doing what? Okay, so difference means subtraction. Alright, so if I want to find the difference between RW and I don't want to count it, I can use that formula. So I'm going to give myself my absolute, these are the absolute value symbols. So they're parallel lines. They're like absolute value symbols are grouping symbols. So whenever you're finding the absolute value of this difference, you go ahead and do the subtraction first, and then you find the absolute value of that value at the end. So after you subtracted them, then you find the absolute value. So if we want the absolute value of RW, and that would be the distance between R and W, which is the same as the length of segment RW, we take the coordinate for R, we're going to subtract the coordinate for W, and that's a -2. What is 4 minus -2? Now you can pick your head up, please. Taylor? Yes, so that's a plus, right? So the absolute value of +6. How far is +6 from 0? Told you when I go fast, it's 6. What if we used the distance between W and R? Would we get the same answer? Does the distance change if we change the order?
No.
So if I count from R to W, it's 6 units. If I count from W to R, it should also be 6 units, right?
Yes.
And that formula will work that way as well. So let's just do it the other way. So -2 minus 4, so the absolute value of -2 minus 4, which is the absolute value of -6. How far is -6 from 0? 6, right? So it doesn't matter which way you use that formula, which way you go, you're going to get the same answer. So RW is 6, and we're going to go ahead and do XW. What's the coordinates of X and Y, Logan? What's the coordinate of X? Yes, and what's the coordinate of Y? All right, so let's use that formula. We're going to do C, coordinate 1 minus coordinate 2. And remember, that order doesn't matter. It just kind of helps the organization there. I can do them in either order because distance doesn't change, but I'm going to do them in this order. 0 is the coordinate for X, minus 6 is the coordinate for Y. So what I have is the absolute value of -6. So that also has a length, right, distance of 6 between those 2 points. Any questions? All right. All right, so let's keep going. So I'm going to try to get done with this by 5 after-ish, so I got to pick up the pace. Midpoint on a number line. A number line is infinite, right? So if we're talking about the midpoint on a number line, we're not talking about the midpoint of the number line. There is no midpoint, right, of something that's infinite. If they ask us to find the midpoint, they're asking to find a midpoint between 2 points that are plotted on that number line. So in this case, example 3, we want to know what is the point that is the same distance from point R and what is the same distance from point W, right? And that would be the midpoint of the segment that you could draw between them. Does that make sense? No? Okay, so let's give ourselves so congruent. Let's look at this definition here first. The midpoint is the point that divides the segment into 2 congruent lengths. So we're looking at this point and this point. So what is the middle point there? Well, we've already found that the absolute value between W and R is 6. So if there's 6 in between them, the midpoint is 3 units in from either point, right? So if I want to go ahead and find that without using a formula on here, I can. 1, 2, 3. 1, 2, 3. So that makes sense. So 1 is the midpoint of segment RW. Does that make sense? All right, so remember, well, I don't know if we can say remember. We talked about congruent yet. Congruent means the same or equal length. So if you don't have that written on your notes, you should. If you watch the video, you would probably have it written there. And there is a formula we can use for that. So we're going to give ourselves a little formula. So the formula would be coordinate 1 plus coordinate 2. And these are subscripts. The order, again, doesn't matter. And it's always divided by 2. So if we're going to use that formula, we already know that the midpoint should be +1 on segment RW. So let's use that formula.
Wait, for RW, I ended up getting the answers. I ended up with the answer being 2.
1, 2, 3, 1, 2.
I did coordinate 1 plus coordinate 2 divided by 2.
Okay.
So I ended up
So
with 1 divided by
-2
2.
plus 4 divided by 2, that would be positive 2 divided by 2, which is 1.
Oh, I see where we're at now.
Make sense?
Yep.
Okay.
I put 6.
Okay. So now let's look at xy. We know the distance, the length of the segment xy, because we found the distance between point x and point y. Those are basically the same things. So we can go ahead and use this formula and find the midpoint of xy. So the coordinate for x, Logan already told me was 0, and the coordinate for y, he told me was 6. Now I'm dividing it by 2. I want to find that midpoint. So the midpoint between these 2 points should be 3, and we can check it out. So let's see. 1, 2, 3 is 3 points from x, and 1, 2, 3 is 3 points from y. So the formula proves out. So we don't have to count. We can use the formula. Yeah. Ananya, are you feeling bad? Do you need to go to the clinic? So then you have to sit all the way up and pick your pencil up and add to your notes as we go. I know, I don't care, but there was no sound. I'm reteaching it. Please pick your head up unless you need to go to the clinic. All right. Segment addition. So segment addition is a postulate. I did not go over that definition. Postulate and axiom. That just means a statement of fact. They're telling us that this segment addition is a true statement. It's kind of a Captain Obvious statement, though. It's kind of like 0 plus any number just gives you the same number, right? We know that. If we have nothing and we add 3, then of course we have 3. If we have nothing and we add 5, then of course we have 5, right? But that's one of those identity properties that you had to learn about in algebra, right? Anytime you add something to 0, you just have whatever you started with. So this is kind of one of those Captain Obvious statements, segment addition. If we've got a segment, and we're talking about segment AC, so from this point to this point, if we put a point anywhere on here, the length of these 2 segments, when you add them, is always going to be the length of the segment you started with, right? So this long segment AC is equivalent to whatever the length of AB is plus whatever the length of AC is. So, Captain Obvious statement, but we're going to use that, and that helps as well. It's a really easy concept to understand, I think. If you watch the video, we're going to be using this postulate where we have to write our own equations. So it gets a little bit more confusing. So we're going to go over the super simple basics, and then we're going to throw the equations in there. So for example 5, if DE equals 2 and EF equals 7, then how long is DF? So now we're looking at this segment. So one of the things that you're going to do to show me work for these kind of problems is you're going to label your diagram. If they don't give you a diagram, you really need to draw it. If they talk to you about segment DF and you don't see that segment DF, you should draw it. If there's a diagram that they use different values for different problems, sometimes you'll get one diagram and they'll give you different numbers. Does that make sense? Does everyone know what I'm talking about?
Yes,
Then sometimes you should just rewrite part of that diagram to keep yourself straight. We're going to go ahead and do label DE as 2, EF is 7. It makes sense. If we want to know how long DF is, we can add these 2 lengths. So now we know that 2 plus 7 equals 9. That's how long segment DF is. But we can use that same postulate in different ways. So if they tell us that DF, the whole thing is 41, and this would be a time where I'm going to draw myself a new segment because I don't want to relabel that same one. So DF, and I'm going to put E somewhere in here. It doesn't have to be look exactly the same length or anything. If all of DF is 41 and EF is 33, so this whole thing put it on my desk. This whole thing is 41, and EF is 33, then how long is DE? What can we do to find out? We can subtract. What would we subtract, Keisha? 41 minus 33. That is one way we can do it, and that is perfectly acceptable on these super simple ones. I'm going to show you how to model that situation with a one-step equation. So I don't know what that is. I know if I add 33 to it, it should equal 41. Right? So now we would, to solve that, we would do just what Keeson said, subtract the 33, and so now I know that x equals 8, and that's DE, because that's the variable I use to represent the length of segment DE. Make sense, Sajari? Make sense, Hector? All right, and then we're going to go ahead and do example 7. And these are the notes from yesterday, Tristan. You were supposed to take on your own, but there was no sound in the recording, so I'm going over them a little bit quicker. Most people took the notes but couldn't hear it, so I'm explaining it. I would not say that everyone is getting the full value out of this because while it's second period, it feels like first period, number 1. So you should be following along in your notes and trying to add something here and there just to keep yourself engaged. Okay, Joel? All right, so DE is 14 and DF is 37. And how long is segment EF? Well, it tells me that the whole thing is 37. What I don't know this time is this length. So I can do the same thing as I did up there. Yep. 37 minus 14 will work. Yep. I'm going to write the equation for that. Taylor, do you have a question? Okay. Did somebody back behind me have a question? I thought I heard a sound. Okay. And now we can do like Tyrone said, we can just subtract the 14 from 37, and that gives us the length of EF. So, is it 23? So EF is 23 units long, whatever unit that is they're talking about. Okay, Josh, you with me? All right. So now we're going to use these with some equations. So, if we define X and PM, so I have to have an answer, I have to know what X is, and I have to know what PM is. Oh, I wrote 4, but there was no 5 there.
Yeah.
Oh, sometimes when I write on this board, it doesn't write that second number.
Yeah, like,
Yeah. Like
earlier
last
when you were
time.
trying to do 41.
Yes,
it's
exactly.
4 colon.
Exactly, Tyler. All right, so here they've labeled the diagram for you. Anangi, do you need to stand up? Please don't put your head back down, and you need to be looking at the screen, right? All right, man. I not remember your name. You have to sit up and look at the screen too. All right. So they've already labeled, here it tells us that PM is 7 times X. Remember, 7X is 7 times X. Whatever X is, the length of that segment is 7 times whatever X is. That's how long it is. We don't know how long it is yet. The MQ is 5 times whatever X is, minus 3. That's how long MQ is. We do know the whole length PQ is 45, and they've given us all that information here. If they don't label your diagram for you or draw your diagram, then you should be doing that. All right, so the segment addition postulate says this segment plus this segment equals the whole length. So now we have enough for an equation. An equation has to have an equal sign. So we know this plus this equals this. So now we can write the equation 7x plus 5x minus 3 equals 45. Now we're just going to combine like terms and solve the equation. We're solving the equation for x Once we know what x is, then we can use that value in our expression here. Now this is not an equation, this is an expression to find out how long PM is. So now I know that x is 4. Well, I know PM is 7 times x. So 7 times 4 is the length of PM. That's where we get the 28. Make sense? That makes sense, Candace? No, you following along with me? Okay. Tyler?
I found out where you put 4, you looked at, you actually put 4 instead of 45, the answer instead of,
I'm good at that, aren't I? Okay, AB measures 5 times y minus 1, and BC measures 4 times y plus 2. If your diagram's not labeled, you should be labeling it. Yeah, you know, they're not all exactly like that all the time, so these two are like that, though. If I have an expression for each of these, and I know the entire length, I can add those expressions instead of equal to the length, and then I can solve for a variable, and then I can find a separate length. Make sense? Alright, so here now, remember this segment plus this segment equals the length of this whole AC, so I can write another equation there. 5y minus 1 plus 4y plus 2 equals 28. I'm kind of failing at my 5 after, but I'm going faster than normal. So combine your like terms. So that's 9y plus 1 equals 28. I'm going to go ahead and not walk you through all the steps on here. 9y equals 27. And y equals 3. So we needed to know what y is. That was one of our questions. But sometimes they don't ask you to find the value of the variable, but the only way to find the lengths of these segments usually is to find the value of the variable. Not always, but usually. Alright, so now we know that the y is 3, and they want us to find AB. So this is the expression that represents AB, so we're going to plug 3 in for y. So 5 times 3 minus 1 is 15 minus 1, which is 14. So now we know that AB is 14 units long. That is the length of AB.
which means that BC is also 14.
Yes, very good. That's exactly right, because then BC would be the difference of the length minus AB.
Or you can just do 3 times 4
Yep,
plus 2.
exactly. 3 times 4 is 12 plus 2 also gives you 14. All right, congruent. I'm going to try to go faster because I'm way over my time. Congruent means same length. I think you already have that in there. Let's underline it or something. I need to know that you're paying attention. So underline it. Congruent. This is the symbol that means things are congruent. Sometimes you'll see that. It means they're the same length. In figures, the little lines are used to show which segments are congruent to each other. Segments that are marked the same are the same. By the same token, segments that aren't marked the same aren't the same length. So these segments, AB and XY, both have 2 little marks. We don't know how long the segments are, but we know it says AB has 2 little dashes, or hashes, or marks, or lines, whatever you want to call them. And XY has 2 of the same little marks. So we know whatever length it is, they are the same. They are congruent. So we're going to say AB is congruent to XY. That means AB is the same length as XY.
AB is equal to XY.
Well, not equal, right? It's the same length, right? It is one of those where technically it's not equal, but for our purposes, we treat them. Do you need to stand up? Do you need to go to the clinic? You can't sleep. Look at me. Pick up your pencil and work with me, and it might help you stay awake. I know it's early. All right. Any questions about what the word congruent means? So if I had, don't write this, but if I had 3 marks here and 2 marks here, now I know that they're not congruent, right? I don't necessarily know that AB is longer than XY. I just know that they're not the same length. Does that make sense? All right. Segment bisector. So we have a segment and we bisect it. What's the prefix bi stand for? Alexa? 2. What does the word sector mean? Anybody have an idea? Sector. Zakai? Yeah, an area, a section, right?
Part.
Yeah, so this is going to be 2 parts, and for our purposes, they have to be 2 equal parts, right? So if you can have a point, a line, a segment, anything that intersects a segment at its midpoint. That means it's going to split it. All right, come on, stand up at my desk, because I'm going to stand the desk for you. Come on. Come on back here. I'll have you stand up. Come on. Come on, come on, come on, come on, come on. All the way back here. Just stand up right here. Right back here. I got a standing desk right here.
Maybe all you need is the rope. That's
All right, this one's broken, so don't put your stuff on it. All right, segment bisector. So anything that splits a segment into 2 equal sections is a segment bisector. We know that this segment PQ has been bisected by line SR because it gives us these 2 marks. 1 mark on PR, 1 mark on RQ tells me that they are the same length, which tells me that line SR is a bisector, or you could say point R is a segment bisector. Does that make sense to everyone? All right, so that means it divides the segment into 2 equal points. You should be writing what I'm writing. Divides the segment into 2 equal points. I'm sorry, 2 equal segments. Or let's use the congruent symbol. 2 congruent segments. Are you writing one of them right? You need a pencil? Okay. All right. Anybody have any questions about what a segment bisector is? Tristan, you write when I'm writing that? Did you just write that down? All right. So now we have some problems. How many? Is this the last examples for 1-3? Okay. All right. So 1-3. What do we know about segment AD, Anange? What do we know about segment AD? What do we know about segment AD, Anange? Sorry? Think of something. Even if it's wrong, say something. It's okay. Doesn't matter. That shows me you're trying. What do those marks on AD mean? Yeah, what do those marks on that line segment AD mean? Sorry? Yep. This little mark right here. What does this mark and this mark mean? What do those marks mean, Noah? Those little dashes on segment AD. No? No things. Jalal, what do those little marks mean? What's congruent? Okay, so there's a point here, point E, that splits segment AD into 2 congruent segments. We know because of these hashes. So we're going to write that AE is congruent to ED. Looking at segment BC, E is also the midpoint or the segment bisector of segment BC. So now we know that BE is congruent to ED, right? We don't know which segments are longer, we know which ones have the same measure, and we know which ones are different. Yes, Tyler?
Do you mean EC?
Yes, I do, thank you.
Also, is there a special name for a segment bisector that dissects multiple lines?
That's a good question, but not that I know of.
Okay.
Okay, if AD equals 30 and ED equals 2 times x plus 6, then what does x equal? So the first thing we're going to do is we're going to go ahead and label our diagram if you did not do that when you watched the video. So now I know that, I've already said that AE is congruent to ED. That means 30 is congruent to 2x plus 6. And in this, when we're talking about the actual lengths, now we can say they're equal. So now we know that 30 is equal to 2x plus 6. So we're not adding them together here, Taylor. Does that make sense? It's a little bit different. So on the first example of that segment postulate, looked like we would add them together and set them equal to the entire length of the segment. Here we don't have the entire length of the segment, but if we know that each segment that makes up that one is congruent, then we can just set them equal to one another and solve for that variable. Does that make sense? All right, so now I'm going to solve this two-step equation, and I'm not going to walk you all the way through that. We've been doing that a while. And so, now we know that x is 2. We already know the length of AE and ED. They told us AE was 30, and we know that ED, yes. Oh, thank you. All right. Yes, 24 divided by 2 is 12. I wrote what I divided by. All right, so now we're going to look at the other segment, BE. 6x minus 7, EC, 5x plus 1. Now here they ask us to find the length of BC. We don't have a numerical value for either of those segments that are congruent. But we do know that they're congruent because they have the 2 marks there. So if they have the 2 marks here, now we know whatever that measure is, they're equal. So now we can use an equation to find that the value of x, and then use x to find the value of either segment. All right, so we're going to set 6x minus 7 equal to 5x plus 1. We know that BE is congruent to EC. And now we're going to solve that equation. Get the variables on the same side. Man, Antoine, take your earpod out. Pick your pencil up, baby. You're doing good. You're awake. That's awesome. I'm writing something. You already wrote that down there? Okay. Don't put your earpod back in. All right. So now we're going to have x minus 7 equals 1. We're going to add 7 to both sides. Now we know that x is equal to 8. But they didn't ask us what x was. They asked us what BC was. You have a question, Tyler, or are you trying to answer for me, bud?
Trying to answer.
All right, I'm going to go ahead and just do what I'm trying to kind of speed through. I'm already over the amount of time I wanted to spend. Okay, buddy? Okay. So x is 8. So I can find the length of BE or EC and then multiply it by 2, and that will give me the length of the whole segment. Does that make sense, Tajari? All right, so I'm gonna find what I'm gonna do EC. So it's going to be 2 times whatever EC is, because EC and BE are the same length, 5x plus 1. So now I'm going to plug 2 times 5 times 8 plus 1. So that's going to be 2 times 41. And so now I know that BC is 82. Any questions on that? All right. Janaya, does that make sense? Sydney, is that good? You have any questions on that? Okay. Last but not least, this is one of those times that I'm going to draw a new line. I've already written all over AD, so now I'm going to make my own AD. So I'm gonna make a new line, and that's what I'd like for you to do on yours. So if you did not do that, let's do that. I think if you watched the video, you probably did that, but
Nope.
now we know that this is congruent. And you notice I did not draw it at an angle. It doesn't matter. It doesn't have to be drawn at that angle. So I know that AE is 8x plus 11. I know that AD, the whole thing, is 20 times x plus 10. So how can I write an equation to find out how long this segment is? Tyler?
You can write, what do you call it? You can do 16x plus 22 is equal to 20x plus 10.
Why, let's see.
Because AE is equal to ED. We don't have the ED yet.
But so if we don't have an expression to represent the length of ED, but we have one to represent the length of AE, and we know they're congruent,
Just use the same equation.
use the same one. So I'm going to actually use the distributive property. I'm going to do 2 times x plus 11 equals 20 times x plus 10. Does that make sense, Lakinya? So I know that this whole thing is 2 times that value, and if it equals this, now I can go ahead and solve for the variable and then use that to find the length. So we're solving the equation. Yep. It should be. Thank you, Taylor. I'm in too big a hurry because I know we got to go over 1-7. All right. Yes, it is. I'm fixing it. Okay. Minus 16x, 16x. 22 equals 4 times x plus 10.
Minus 10. 20 is going to equal 4x equals 12 divided by 4. Divide both sides by 4, and you get x equals 6.
Perfect. So what did they ask me for? Did they ask me to hold
They
it?
asked
Nope,
for
just for
ED.
ED. All right, so we know x is 3, and ED is 8x plus 11.
So
So we're just going to
8
plug in.
times 3 plus 11 equals 35.
So now we know that ED is 35.
And if you feel like taking a long way, if you feel like seeing how much AD is, it's 70.
Yes, you can multiply by 2. Okay, right now get out your 1-3 worksheet, everybody. Get out your 1-3 worksheet. Is there anybody that's already done it? Okay, if you've already done it, I want you to come up to my desk and check it for mastery. I'm going to give you guys 20 minutes to work on 1-3 if you did not. If you did not, if you did do it, you need to bring it up and check it for mastery. And once you do that, I'll let you know what else you can work on until we're going to take notes on 1-7 in 20 minutes. I'm going to set myself a timer. Maybe. Alright, I'll just put it out.
Wait, that's the 1.2.
Yes, hit the back page of that. And no one should have your head down.